Okay. I think yes, we have to start from here. Binomial PMF. Okay, I can write it. So this is the binomial coefficient. As I mentioned last time, this is the binomial coefficient. This is the probability of success. Probability of success. Okay. So n is the number of observations. Total observations. X is the success count or successes, number of successes. Okay, clear? Okay, this is how you mention, how you denote the binomial PMF, or you can write it like BIN X semicolon N comma P. N is the total number of outcomes, so trials, number of trials. P is the success probability. Or simply you can replace this one, capital B. And also you can simply write it N comma P. That's fine. You don't need to mention. You don't need to mention the variable. Okay, clear? Okay. Okay. Check the previous example. I think you may remember that we had, I think, an assembly process. We had a number of defective problems, right? So probability of a defective item is 0.1. So number of defective is my success. So it was 0.1. Okay, total number of trials is 3 because I checked 3 times. So if you have this one, what is this? Probability of having a one defect, having a one defective component, something like that. Okay. So probability of X equal 1, right? Having a one defective, probability of having a one defective is this, right? So you can simply plug those values into a binomial distribution or binomial PMF. So total is 3. Number of successes. Here I'm asking only for one defective. So 1. So 0.1 is the P, your success probability. So P to the power X. Remember P to the power X. X is 1. X okay, whatever, that's fine. Okay. So this is 1. Oh, sorry. Okay. And 1 minus P to the power N minus X. So that's why 3 minus 1. So simplified, and you can get 0.243. Okay. N is the number of trials or number of observations, or you can say number of trials. Yes, simple N is the number of trials. In this case, I'm checking 3 times. If you don't remember, please go to, I think, 2 slides back. You can find the question. Okay. Yeah, always N comes here. N comes to this point, and your success, number of successes come to this point. Okay, don't mix it. Okay, okay, that's the binomial coefficient. Okay, now let's check about CDF. What's going on with binomial CDF? Okay, cumulative density function. Yes.
Can you please go to previous slide?
Yes. Hold on. Why this is not going? Okay, this one. Yes. Sorry. Sorry, this one. Yes.
Yes. So what is the relation between X and N?
X and N mean here K equals N. Sorry, K equals X. Okay. N mean number of trials. Total number of trials. Total number of trials or outcomes. Clear? Here we have trials, right? We picked 3 items. No, we pick items 3 times. Clear? So X is the number of successes. So if you remember, I think, sorry, here, See, X is the number of successes. So X definitely less than or equal simple len. It cannot go further than. It's possible, right?
Yes.
Clear? Okay.
Okay, okay.
Okay. So
Yes,
success
sir.
can
Thank you so
be,
much.
yeah. Success, number of success, success, it depends on your problem, okay? It can be a number of heads, tails, whatever. Okay, CDF, binomial CDF. CDF always counts, or it always consider whatever from probabilities, whatever from the beginning to that particular point. Okay, that's the normal idea of PDF, sorry, CDF. So same here, okay? So CDF considers probability of capital X less than or equal simple x. So you can denote, we can calculate that using our binomial PMF. Okay, this is how we do it. It is summation. Don't confuse with this simple y. It is just another variable, another letter. Okay, because if I mention x here, x equals 0, you will confuse with that x on the top. Okay, so here y mean number of successes. Okay, so number of successes goes from 0 to x. X mean your number of successes. Okay, so that's why we have mentioned y here. Okay, so don't confuse, y is same as x. Okay, number of successes. Okay, so since you have y here, we mention it here as well. Okay, same notation. This part is the binomial PMF. Okay, but you have to take the summation. You have to go through each and every individual pieces, collect them, and you will have the probability of x less than or equal simple x. Okay, so simply you can denote it like this. But if you are writing a CDF, don't forget this summation. Okay, summation should be there. Okay. Yes, refer table A1. I'll show you the table A.1 later. Okay. I think I don't share. I didn't do. Yeah, I did. I think I didn't upload that table, but today I'll upload it. Okay. Okay. Try to do this example. How likely is it that the product has one or fewer defect? Same question. Okay, what we used in a few slides back. So, what is it? What is likely is that the product has, okay, one or fewer, which means you need to find probability of capital X less than or equal 1. Clear? So this means, since we are considering a discrete variable, okay, so this means simple x start from 0, right? So probability of capital X equals 1 plus probability of capital X equals 0 and 1, right? Because simple x values are 0, 1 and 0, 1, 2, 3, right? Up to 3, yeah, up to 3, because we have 3 trials or 3 occurrences. Clear? So 1 is included because you have a equal sign here. Clear? So how do simply you can find these individual pieces and do it. Okay. Otherwise, yeah, same thing we have mentioned here. Probability of x equal 1, simply what? Plug the values to the binomial PMF and find it. What is the binomial PMF? N choose x, I mean n here is 3, we need 0, right? Probability is 0.1 to the power x, 0. 1 minus 0.1 to the power n minus, n is 3, n minus x, plus probability of x equal 1. You have 3, it doesn't change. Now x is 1. P is 0.1 to the power x, x is 1. 1 minus 0, 1 minus p, 1 minus 0.1 to the power n minus 1. So simply do this calculation and you will have the answer for this. Okay, so this piece x equal 1, which means this part is this. Okay, I think they have mentioned, yeah, 0 they have given here, so I'll I'll erase what I wrote. Okay, because it's not clear here. See, so you can simply add these two and get your answer. Yes. They have to give you. Otherwise, we don't know number of trials. Okay. Here, because it's referred to that question. Here, n is 3, because still we are using the same question, same example. Okay. Clear? This is how we deal with the CDF or binomial problems. Here, actually, you don't. This is the CDF, right? Probability of x less than or equal 1. This is the CDF, right? Summation. So simply, this is how we deal with CDF as well. Okay. Okay, check this one. Suppose that 20% of all copies, 20% means simply this is you can convert to the probability value 0.2. Particular textbooks fails. Okay, textbook fails. Binding is strength. So x denote the number of number among 10 randomly selected copies. Okay, that fails. Okay, x mean fails. So we have 10 randomly selected copies. Oh, sorry, 10 randomly selected copies. So this equals to simple n. This is your capital X, and this is the, what is your X? Fails the test. Okay, so your success is fails the test. Clear? So what is the probability? Simple P is 0.2. Okay, clear? So it can be 0, 1, 2. So x can be 0, 1, 2, 3 up to 10 as well. Okay. So we need to find the probability that at most 7 fails, which means probability of capital X here it should be at most, which means maximum, right? Maximum 7. Clear? This is what we need to find here in the first bulletin point. Okay, so next one, probability that exactly 7 fails, which means capital probability of capital X equals 7. That between 2 and 8 inclusive mean including 2 and 8. Okay, so you need to find probability of capital X between 2 and 8, including 2 and 8. So these three you need to find. Clear? Okay, is there any problem how we convert this written question into our notations? Is there any problem with these notations, how we convert them? Okay, so let's check this. So n is 10, p 0.2. This is your binomial PMF. So this is your binomial PMF. Okay, first one, x less than or equal 7, right? So what you have to do is you have to, in general, just forget about what they have mentioned for a moment. What you have to do, you have to add everything from, 0 to 7, right? Something like this. Probability of x equals 0 plus probability of x equals 1, right? Up to, probability of x equals 7. Is that clear? Okay, but this is little bit a pain, right? So what we do is we use CDF, right? Simply we use CDF. Uh, so yeah, they have mentioned that here. See, same thing they have mentioned. We need to do this, but uh, let me go back and share that screen with you. This table, appendix, this table, I think A1. I will share share this with you. I mean, I'll upload this into the Blackboard later today. This appendix, it gives us cumulative binomial probabilities, which means, oh, what's going on? I don't know. Sorry for the technical problems. Okay, so this shows uh, um, cumulative binomial probabilities, which means binomial CDF. Okay, problem is there are limit number of trials here. I mean, only you can find only n equals 5, n equals 10, n equals 15, something like that. Okay, between values n equals 7, 8 is not there. Okay, so you have to be careful with this. If you have that values n equals 5, n equals 10, no problem. You can simply use this table and find the values. Okay, so let me go back to our problem. So it is what? We have n equals 10. Yes, we can use that table. So we need to find less than or equal 7. Okay. So these are the probability values. These are the n values. Simple n values. I mean, these are the simple n values. So you have to find 7, right? So you have to go up to this one. N is 10. So this is the table you need to refer. Clear? Simple n equals 10. So what do you need to find? 7, right? And what is the probability? 0.2. So go down and come with this one, this side. So what can you see? This is the value, right? Clear? 1 is the value. Okay? Okay. So yes, see, answer is 1. Which means probability of capital X less than or equal 7 is 1. Okay, clear? Don't confuse with that. 1 is again a probability value. Okay, that's the maximum. It doesn't matter. Okay, which means simply what happened? Probability of X greater than 7. What's the probability? Let me explain. Okay, if you consider the CDF, okay, please don't confuse with these values. It's definitely probability value 1. Okay, so once you consider CDF, 0, 1, 2, 3 up to 10. So from 0 to 1, value is there a value? I don't remember that. I think maybe or may or may not. Okay, that's fine. So value when x after, I mean, when x equals 1, jump to 1 value. See, remember that CDF, jump, jump, jump. So when x comes to 7, it jumps to 1. Okay, I mean, I'm talking about the CDF. Okay, just think about CDF only. So x equals 1, sorry, so x equals 7, it jumps to 1. What happened? So it goes like this. When x equals 8, what happened? Can it jump? No, it remains same, right? It remains same at 1. Okay, that's the CDF. That's another story. If you need to find probability of x greater than 7, simply you have to take the negation. That's the easiest way. So 1 minus probability of x less than or equal 7, right? Which is the probability of x greater than 7. So it is what? 1 minus 1, 0. Clear? So this is the way how we deal with. Only problem here because it is 1. So, okay, so don't confuse with that. Clear? So this is the easiest way to use, this is the easiest way to calculate your cumulative probabilities by using this table. By using this table means this table, okay? But you have to be careful with these numbers. First, you have to go to that number and try to lock that particular table, okay? Then find the values. Yes. Yeah. Total probability? Yeah. Yeah. Okay. So it doesn't matter. You don't have to worry about these values. They have calculated and it's there. Okay. So don't worry about that. They have taken by using the binomial PMF. Okay. Using any computational method, they have taken this. So see, n equals 15, you have values. N equals 20, you have values as well. Okay. You have values up to 25 only. After that, you have to go to another technique or do by hands. Okay. Next one, see, x equals 7. Remember that how we find equal, the probability of a point using CDF. Okay. So it comes from 5 to 6, jump at 6, 6 to 7, jump at 7, right? So we need that value. So you have to find it, capital F, you know what is capital F, right? CDF value at 7 minus capital F at 6. F7 minus F6. That gives you the probability at that point using CDF. Okay. If I draw it like this, here it is 5, let's say 6, 7. Okay. I'm not talking about the values. Just for a moment, consider probability value is here. It counts to 6 and it jumps to this point, right? Go like this. 7 is not included. Go up. 7 value is here. So 7 to 8, it has a value, right? So once you need the value, this value, only this value, okay, what you have to do? You have to simply get this value here and subtract whatever you have, which means up to this point. You have to subtract whatever whatever you have from here to here, 6. Because you need 7, right? So we have to subtract this. That's why we mentioned F7 minus F6. These are CDF values. So clear? Is that clear? So as you ask, if we need to find the probability of x equal 25, what we have to do? F25 minus F24, right? So you ask what happened if we need to find probability of, for this example, probability of x, probability of x equal 25, something like that, right? So you can see up to 24 value is what? Up to 24, CDF value, cumulative is 1. So up to 25, including 25, 0, 25 defectives, yes, all are defectives possible. So from 0 to 24, CDF value is 1, which means it, I don't know where it come, it equals 1 from 3. So 3 to any value, it is 1, okay? So whatever at 25, 1, right? 25, 1. So F25 minus F24, what is the value? 0. Clear? Is that clear? Because why? Actually, it depends on the problem. Okay, it depends on these values. So don't fix that idea. The maximum is always 0. No. See, check this one. What is the value for 25 for this case? 24 is 0.22. So F 24 minus 25. So what happened? Cannot find it, right? Because it's not there. In this case, okay. The problem is, okay, with this, see, these probability values are different. Here, the probability value is, which means having a defective item is always like 1. It's very close to 1. I mean, I'm talking about the last column, this column, okay, 0.99, which means it's almost 1, which means once you pick item, it's a defective, something like that, right? So, yes.
Currently, like there was a question for 25, right? Have to find for 25. So f of 25 minus f of 24. So we will get like the number of defective items, right?
Yes, yes.
When so how could it be a 0 value?
I'm telling that you cannot use this table if you need to find 25. Can you get that? Why? See, I told you this value, okay, probability of having a 0 defective, I mean 0 only, less than or equal, oh no, there is no less than or equal, just 0. It is 0, okay, which means from 25 you will be having 0 defectives. It is like impossible because you probability of having a defective is 0.99. I mean almost 1. But it's when you calculate it like see, these all values are 0, but once you come to like 22, no 22, right? See 22, it start to get some values, which means it is 0.02, very small probability. So 23 increasing, right? So likewise 24 is increased up to 25. You have to calculate that. That value can be like what? 0.3, something like that. You have to calculate that. It's not there. Yes, manually mean using calculator. I think there's a function in your graphing calculator, so you have to check it. I mean, some calculators, they have binomial distribution in the calculator. I mean, once you get it, you have to just plug the values, something like that. But I'm not sure about your calculator. If it is not there, you have to do it by hand. Clear? But don't worry, in the exam, I'm not going to put you in a trouble, okay? But the idea is you cannot find that maximum value from here because of the probability values, okay? But if you have a small probabilities like 0.01, 0.02, yes, you can find it, right? See, for this one, you can find the maximum, okay? But that case, it is hard to find. Clear? Okay, that's a great question. So, guys, do you have any questions?
So
yes.
What so we cannot find for the maximum values, right? As you currently told. So for this,
so don't confuse with that. Always don't think like always we cannot find the maximum. Sometimes only.
Sometimes, sorry, yes, sometimes. Yes. So for the current table, if we are asked for x equals to 15 when the probability is 0.10.
So what is the what you ask? P
like,
equals
when the probability is 0.10, we have to find it x equals to 15.
15, okay, here, okay, check this one, yes.
So will it be 0?
Yes, how do you find the point probability? Capital F. Oh, it is hard to write in the PDF. So you have to find it like capital F of 15 minus capital F of 14, right? Clear?
Yes, sir.
Probability of capital X equals 15. This is you are going to find. So what is this value? It is 1. What is this value? It is 1. So probability is 0. Yes. Clear?
Okay, okay. Yes,
It
thank you,
depends on the
sir.
values, right? If you check this one, see, it's not 0, right? It depends on
Yes,
these probability values. Clear?
yes, thank you, sir.
Okay. Okay, let me share again this PowerPoint. So if you need to find the x equals 7, f7 minus f6. Okay, so this is the value. So how do you find f7? Go to the table, which means n equals 10 table part. Find f7 and find f6 based on probability value is 0.02. Okay, 0.02 column and 7 again 6. Okay, get the subtract them and find the value. Okay, here f7 is 1, f6 is 0.99999. So value is this. Clear? Okay. Otherwise, see, you have to do this calculation. Since they ask a probability at a point, you can simply plug x equals 7 into a binomial PMF, not the CDF, PMF. But calculations are going to be a little bit hard. But if you use your calculator, that's fine. Okay. Then you will get the 0.001. Okay. Clear? Okay. Same as your question, if you need to find this probability of P, probability of x equal to 25, plug x equal to 25 into this. I mean here 7 is not 7, 25. So you can calculate it. Okay, clear? Here you cannot find it because we are this based on 10. Okay, n is 10. For your question, you can find it. Okay, so don't confuse it there. If we need to find the value in between x greater than or equal 2 and less than or equal 8, what you have to do? F8, that's the maximum, right? Including x 8 minus subtract what? F2, capital F2. No,
I think so. It
2
will be
is
F1.
included. Yes, sorry.
I think so. It will be F1.
Yeah, that's F1. That's what I'm talking about. Thank you. F1. Why? F2, I mean, probability of x equal to should be in this calculation. I mean, it should be included. Clear? So that's why we subtract F1. 1 at 0.2, it goes up. So we need that 2 value. So it's not F2. Okay, it is not F8 minus F2. Okay, it is not that. It is this one. Clear? Okay, so don't confuse with this one. I mean number 2, this one and this one. Okay. Okay, think like this. If you need to find a point probability like x equals 7, what you have to do? F that value minus f a value just before that value. Clear? For an example, if you need to find probability of capital X equals, let's say x x3. Okay, this is just an example. So what you have to do? Capital F x3 minus capital F x2. Okay, this is how we find the point probability. Once you need to find the probability of, let's say, capital X less than or equal simple x3 greater than or equal simple x1. No, 2. Okay, if you need to find this, what you have to do? Capital F x3 minus capital F, not x2, just before that, x1. Okay, that's the easiest way to remember this. Okay, clear? So you don't have to think too much. If you have in your exams, if you have this kind of question, just apply that idea. Okay, because in the question there's no time to think too many things. Okay, clear? Okay. Mean of the let me check the time. Okay, 43, we have enough time. I mean, yeah, I think I can finish binomial distribution today. There is a few slides. So mean of this binomial distribution we can calculate, which means expected value. Simply we can calculate n times its probability, n times p, n times success probability, np. Okay, if n is 3, success probability is 0.1, value is expected value, or mean is 0.3. Okay, here errors mean we are dealing with errors, that's why error. Okay, okay, so variance of the binomial distribution you can simplify using this np times 1 minus p. So this 1 minus p you can simply denote by q. So that's what they have done. Okay, np times 1 minus p, it gives you the variance. If you need the standard deviation, take the square root. Okay, so this is the example for that.
Hello, sir.
Yes.
Here the Q represents the number of
1 minus p.
successes.
1 minus p.
Oh,
See
okay.
this one.
Okay.
It is just a
Yes,
note.
sir.
It's just a letter. Okay, it is 1 minus p.
Okay. Yes, we have just
Okay.
substituted in
Yes,
right?
exactly. Okay, so if you need the variance, you can find it like this. Okay, don't think too much about the units. Get here, errors squared by, you have p, I mean 2 probabilities, p times 1 minus p. So probability defined on errors, error probability, that's why error squared, error times error squared. So don't worry about the units. Okay,